Now let's finish off solving equations by looking at the tangent equation. Part A, find all possible exact solutions for the tangent of an angle equals 1, where t is in radians. So again, we have our unit circle, and what we know is that for a tangent of an angle to equal 1, well, tangent is equal to sine over cosine, so the only way we're going to produce an output of 1 is if the sine of the angle and the cosine of the angle are the same, exactly the same. So that's happening at pi over 4, and that's also happening at straight across at 5 pi over 4. So this one's happening in quadrant 1 and quadrant 3. But if you recall, so let me write this down actually. I'm going to say that t is equal to pi over 4. We could also say that t is equal to 5 pi over 4. Now, because it's asking for all possible exact solutions, I need to write this for multiples of the period, right? Now, the tangent function has a period of pi, you may recall. If I add pi to pi over 4, I get that solution of 5 pi over 4. So all that we need to say for the tangent is that the solutions for the tangent function are the angle that the calculator might give you if you're using a calculator, and then multiples of that period. And multiples of that period are going to be written as plus pi k, where k is some integer. So even though I know that 5 pi over 4 is a solution, I'm being a little redundant because what I can say shorthand is that the solutions are pi over 4 plus multiples of pi, where those multiples are represented by k being an integer. So if k is equal to 1, then I get my solution of 5 pi over 4. If k is equal to 2, well, then I have the solution of pi over 4 plus 2 pi, which would be 9 pi over 4. And I can keep going around and around and around, and I can go backwards or I can go forward. So k values can be positive 1, positive 2, positive 3, or they can be negative 1, negative 2, negative 3. Let's look at one more. Find all possible solutions rounded to 2 decimal places where the tangent of theta is equal to 0.55. So let me just write this whole thing out. I'm going to write tangent of theta. This is the original problem. If you have the ability to write the original problem down when you're solving these, that is always a good idea because then the reader doesn't have to look that far to see what it is that you're doing. So the tangent inverse and the tangent undo each other, and I'm left with a theta value of, let's see, I got I'm going to go ahead and write this out, 0.50284321109. Now it says to round to 2 decimal places, so I'm going to say that theta is approximately 0.50. And that more solutions can be found simply by adding multiples of the period, which is pi, where that k value, or the multiples of pi, are represented by an integer. So that would be my final solution for this one.